Hello everyone and welcome to General Chemistry. So this is chapter 1, Introduction to Chemistry. I'm using here the book Introductory Chemistry Concepts and Critical Thinking, 7th edition by Charles H. Corwin. So let's get started. Let's look into the learning objectives of this chapter. So at the end of this chapter, you should be able to first describe the early practice of chemistry. Second, identify the three steps in scientific method. Third, describe the modern practice of chemistry. And lastly, conclude that chemistry is very relevant in our daily life. So let's begin our discussion. We'll look into the early practice of chemistry or the evolution of chemistry. So the early concept of science began with different civilizations, ancient civilizations like Chinese, Egyptian, and Greeks. But in this case, we'll focus more on the Greeks. So let's go back to the past, and this is around 600 BC, and this is the time when Greeks speculate or believe that the universe is composed of a single element. And there's a personality here, Thales of Miletus, the founder of Greek science and math and philosophy. He suggested that that single element is water. So he said the universe is made up of water. He also said that the earth is a dense flat disk floating in a universe of water. So this is just some speculation according to Thales. And then he added also that air and space are less dense forms of water. So that is around 600 BC. Then, years later, other Greek philosophers also proposed that air is the basic element that comprises the universe. Others said that it's fire, and some said it is earth. Then, at around 450 BC, there's another Greek philosopher whose name is Empedocles. He observed that when wood is burnt, there's a smoke that rises slowly. That smoke is a representation of the air. We can see the flame, that's the representation of the fire. And when you put some cool surface over this fire, there are little water bubbles that came out. So that is a representation of the water element. And after the burning process or the combustion process, you are only left with charcoal or your ash. And this is a representation of the element of earth. So from this observation, he interpreted that objects will be made up of four basic elements. It's made up of air, fire, earth, and water. So since then, the Greeks believed in four basic elements like air, fire, water, and earth. And they believe that all substances that we can see, these are combination of these four basic elements in different proportions. So here's a representation of that four elements. So you have your air, fire, earth, and water. And with their corresponding description, like fire is hot and dry, your earth is dry and cold, water is wet and cold, and air is hot and wet. Okay? So since then, this is the basis nila of the composition of different substances. It's made up of four basic elements: air, fire, water, and earth. Then, at around 350, pardon, this is 350 BC, the famous Greek scientist Aristotle adopted the same idea that substances or different substances will be made up of fire, earth, air, and water. In fact, he also added the fifth element. So he called this the ether. So Aristotle is very very famous, or his influence is so great that his opinion dominated other Greek philosophers. And this idea lasted for almost 2000 years. So no one dares to contest Aristotle during that time because he is the most influential scientist of that time. Okay? So forward around 1951, there's another personality in the name of Robert Boyle. He published a book called The Skeptical Chemist. So in this book of Boyle, he said that theoretical speculation is worthless unless it was supported by experimental evidence. So you should always prove, according to Boyle. So you should always prove your speculation. And this gave birth to the development of the scientific method. And this development of the scientific method marked a turning point in scientific inquiry. And it's the beginning of the modern science. Okay? So modern science started at around the time of Robert Boyle's publication of this book, The Skeptical Chemist. So let's answer this question, what is science? So science can be defined in this manner. It's the methodical exploration of nature followed by a logical explanation of observation. And in this way, you should apply the scientific method. So how do you explore nature through this logical explanation of observations? You conduct an experiment. So in an experiment, it involves scientists who in who explore the nature according to a planned strategy. It's a planned strategy. So you don't just experiment. You need to plan it. Okay, and you should also make observations under controlled conditions. So let's define scientific method. This is a systematic investigation of nature, and it requires proposing an explanation for the results of an experiment in the form of a general principle. So during your elementary days, this is always discussed your scientific method. And as you can see in the description, you should propose an explanation. That proposal, the tentative or initial proposal of a scientific principle is called your hypothesis. During our elementary days, we often call this hypothesis as the educated guess. So the educated guess. So you still guess what is the principle behind it, but it's um it's based on some principles. Okay. So after further investigation or your experimentation, the original hypothesis may be rejected. You may revise it, or you may accept it, or it could be elevated to the status of a scientific principle. So this is just a summarization of the three steps. So you perform a planned experiment, you make observations, and you record data. If you have your data now, then step two comes in. This is where you analyze the data and you propose a tentative hypothesis to explain the experimental condition. Okay, so this is the time you conclude. Okay, and step three, conduct additional experiment to test the hypothesis. So if your hypothesis and your evidence support the initial proposal, then hypothesis may become a scientific theory, or it could also become a law. So there's a difference between a theory and a law. In visual presentation, this is your scientific method. It starts with your observation, your question, then you formulate your hypothesis, you conduct your experiment, and from that experiment, you gather data, you analyze it, then you conclude. And that is your result. So let's give an example, a concrete example of this scientific method. For example, you notice that if you add fertilizer, your plant grows well. So you ask yourself, which type of fertilizer works the best? So if, for example, you have fertilizer A, B, and C. So you want to test which of the three fertilizer will make your plants healthier, or yeah, like that. So you formulate your hypothesis, your educated guess. Among the three, which one will make the growth fastest? So let's say you stated here that plants grown with fertilizer A will grow the fastest. Take note, it's in the future tense will grow. So because you don't know yet the result, so you are just speculating, you are just proposing an explanation. So you say here that fertilizer A will make your plant grow fastest or faster. So now you make your experiment. So how do you make the experiment in this setup? So for example, you have a plant, you will use this plant. So every plant should be constant. So for example, the plant that you will use, that should be the same for the three pots here. Then the amount of sunlight, the amount of water that you will provide to the three plants should also be equal. So what will be the varying factor here? So the varying factor here is the fertilizer, the type of fertilizer that you will use. So let's assume that you already um, planted your plant, then you apply same amount of water, same amount of sunlight with the three plants, then you apply the fertilizer. Then now you observe. Now you also observe, you gather data, and you notice that plant A or pot A has a very good growth of the plant. While in letter B and pots B and C, you can see where there is a stunting of the growth. So you have now your result. And what's your result? That plant A or pot A grows well with that fertilizer. So you now go back to your hypothesis. If your hypothesis here, you stated here that fertilizer A will result to the faster growth of your plant, you check it here in your conclusion. You check it. You counter check your hypothesis. Is your hypothesis rejected, accepted, or revised? So in this case, you've proven that your hypothesis that plant grown with fertilizer A will grow the fastest. So your hypothesis is correct. So you now conclude that fertilizer A is the one suitable for the growth of your plant. So this is how you apply your scientific method in that very simple experiment. Okay? So let's say that the, that that experiment was repeated several times. So you already gathered some sufficient evidence. So that may become a scientific theory or a law. So I said a while ago that there's a difference between a theory and a law. So an example of a theory in chemistry is your atomic theory. And then we have law. One example is the law of conservation of mass. So a natural law will state a measurable relationship. There's a mathematical relationship between the variables. So if of this text here, so for example, you have an experiment, you analyze the initial observation, and then you conduct this experiment all over again, and you still arrive with the correct hypothesis, or your hypothesis remains accepted, then it could either become a scientific theory or a natural law. So how do you determine if your hypothesis becomes a theory or a law? You ask the question, is the proposal measurable? So if it's measurable, yes, then that becomes a natural law. But if it's no, then it it becomes a scientific theory. Okay? So that is how you can determine the difference between the natural law and a scientific theory. So you can again formulate formulate a mathematical relationship, a measurable relationship between the two variables. But if it's not, then you have a scientific theory. So let's go back to the evolution of chemistry. Then this is after after death na siya. So this is 8th century AD. This is the time when Arabs introduced alchemy. So the person who conducts this alchemy, we call them your alchemist. So alchemists, they also conducted simple experiments. They also believe in the existence of a magic potion with miraculous healing powers, and they also want to find the philosopher's stone. And they also believe that lead can be transmuted to gold. So alchemy is considered a pseudoscience, a false science, because they didn't arrive with the transmutation from lead to gold. Okay, and they didn't find the that healing potion with miraculous healing capabilities. But alchemists, they also paved the way for modern chemistry because in their experiments they also created the first laboratory apparatuses or glasswares. So that is their um, significant contribution to the study of chemistry. Okay, and again, they also conducted simple experiments and they followed scientific method. Okay, then again, fast forward around the late 18th century. So late 18th century AD, there's a French chemist whose name is Antoine Lavoisier. So he organized chemistry. He wrote two important textbooks in chemistry and built a magnificent laboratory. So because of these efforts ni Antoine Lavoisier, he is often called the father of modern chemistry. Okay? But before we dwell in the modern chemistry, let's define chemistry first. So chemistry is a body of knowledge that studies the composition of matter and its properties. So elementary pa lang tayo, when we hear the term matter, we always say that matter is anything that has mass and occupies space. So anything that has mass and occupies space, that's called matter, and that is under the study of chemistry. You study matter. So chemistry is divided into different branches. So these are just some of the branches of chemistry. So the most notable ones are your organic chemistry, inorganic chemistry, physical, analytical, and biochemistry. So when you say it's organic chemistry, this deals with the study of substances that contains carbon. Okay? Then other than that, if your substance do not contain carbon, then that falls on the study of inorganic chemistry. Okay, so that's the difference between organic and inorganic chemistry. For physical chemistry, this offers some theoretical and mathematical explanation for chemical behavior. Okay, and for biochemistry, so you have here the term bio, which is a Greek word for life. So biochemistry studies substances derived from plants and animals. So anything that is living. And we also have the, for me, the toughest chemistry, which is your analytical chemistry. So I allotted here a special slide for analytical chemistry because in analytical chemistry, you can uh, you can divide it into two, can perform qualitative analysis or quantitative analysis. So when say quantitative, you ask what substances are present in the sample. You just want to know what substances are present in your sample. If you want to quantify it, so it means you want to measure it, then that falls to quantitative analysis part of analytical chemistry. So there's a lot of branches of chemistry. For example, you have your green chemistry, also known as your sustainable chemistry. So this one is all about the design of processes that reduce waste and reduce substances. Okay, so you also touched in some studies about environmental chem. Okay, so in this slide, I'm just showing here that chemistry provides support structure to other branches of science, like in medicine. So whenever we are sick, we take medicines or drugs, and that is also a product of chemistry. So chemistry with other fields like chemical engineering, in the study of environment, in agriculture, especially in fertilizers, in forensic science, atmospheric science, and a lot more. So chemistry is linked to other fields of science. That's why we always say that chemistry is the central science. Can always explain things through chemistry. So that makes it the central science. On this slide, I'm just showing here the various products of chemistry. As you can see, we have different products like in cooking, in creation of batteries, in the field of food, we have paper that's made of cellulose, in drugs, soap, petrol, concrete, plastic, clothes, wrapper, and etc. Okay, so go on that chemistry is the central science. in the understanding of the world around us. So you always in your daily life. So these are so often free. So you can perform experiments on experiments. So it can also benefit the society. It is a principle. Give numerous opportunities and will never run out of interesting topics. Okay? So I hope you will find to helpful in your degree and not um, you will not hate this subject. Okay, summary what I said. We have here use the scientific method to investigate the world around them. So when we say we have scientific method, you always follow the step-by-step process. You plan an investigation, you make full observations, you gather your data, and then you interpret your results. Okay? Second point is you need to perform experiments. So experiments need to is or your educated yes, this is your initial proposal. And if you perform your experiment numerous times, this will lead to the formulation of a scientific theory or a natural law. Again, the difference between the two is your natural law, you can make a measurable relationship between the two variables. If it's not, then you have a theory. I also discussed here in this lecture video that chemistry is a social science with many branches. Okay? The impact is felt in many aspects of our daily life. Okay? So that is our chapter number 1, the introduction to chemistry. Thank you for listening.